First question I got is this question. Mr. O'Quinn, you out there somewhere? Usually he's here. Okay, yet another one. I think this is one that we did the other day, but we'll do it again just in case. I think it was one of those that you plug in infinity. No, this is the one that basically says infinity over infinity or whatever. I told you these would be good test questions because they're short and sweet. So f of x is equal to 300. F of x is approaching 300. And g of x is approaching 0. Notice that you don't have an equal sign in there because they're not equal. But g of x is what? What is g of x? Somebody tell me what that means. That means I want you to talk to me.
It's less than 0.
What does that mean, though?
It's negative.
It's negative, so I'm going to put a negative right here. Okay? So I'm going to take that highlighter, I'm going to take that pink highlighter, and I'm going to highlight that negative because that changes the whole kit and caboodle no matter what that 3 is. So you've got positive 300, you're approaching positive 300 over a negative, basically approaching 0. And that's going to give you basically what's a negative over a positive or a positive over a negative. Plug in infinity, you're going to get negative infinity. So that should be your answer. Negative infinity. Okay, so hopefully you feel good about yourself there. And these are all 2.5 and 2.6 questions, which is good. Now this question is pretty much the one we did the other day. That's the one I was looking for. So for those of you that need it, let's go ahead and do it. Because why would I go over this question again? The reason I'm going over this question again is because it's a test question. Just the reason I went over that last question. So at least I'm telling you it's a test question. So limit as, I'm going to write it down and let y'all work on it for a second. Limit as w approaches infinity of 24w squared plus 6w. Somebody count in your notes. How many did we do yesterday like this? I will say 3.
4 at least.
Somebody give me a count. I think 3.
I think it was 3 as well.
Say again?
It was 3.
3. 9w to the 4th.
Well, we did 3 with the square root, and then we did a couple without the radical.
Okay, so this one's got a radical. So I'm going to take my handy dandy pink highlighter and my yellow highlighter. Well, whatever. So I'm going to put square root of w to the 4th is equal to w squared. So I'm going to divide the top by w squared. Now please remember what I told you yesterday. I told you, you do not have to do all this. But if you've never seen this before, or if you don't know how they do it, you might want to write down every step. So 24w squared plus 6w plus 5, and then the square root of 9w to the 4th plus 5w cubed. And then I'm going to divide the top by w squared. And another reason I'm doing this is because these questions were sent after yesterday's class, so somebody still had a question. And divided by w to the 4th, w to the 4th. Now, the reason I have to divide the bottom by w to the 4th is because I can't distribute across a radical unless I have a radical. It's the only way I can. The square root of a times the square root of b is the square root of a times b. So I cannot distribute, I cannot divide by this w fourth, the square root of w fourth, unless I have a radical with it. That's why. Now, what's going to happen is, I'm going to go ahead and do this third step for you. Limit as w is equal to infinity. And I'm going to take my red pen, and I'm going to mark that out. And that's going to mark that out. And that's going to take that out and leave that to the first. And that's going to take that out and leave this to the first. So here's our last limit before we actually plug and chug. 24 plus 6 over w plus 5 over w squared over the square root of 9 plus 5 over w. I may have asked y'all this before. Do y'all see the border on the side of my visualizer? Do you see the icons right here and the camera right here, or is it just you don't see anything?
I can see everything.
Yeah,
Like
I see
on the camera.
I don't want that. There we go. How about that? There we go.
Yeah, that's good now.
All right. Now, what happens? What happens to the? I'll take my red pen. That's 6 over w. When you put a infinity there, an infinity there, and an infinity here, what happens? They all go to what? They all go to 0. And that leaves you with 24 over 3, which is 8. Okay? Question, great, complaint.
So you said the big, whichever is bigger on the bottom makes it 0, right?
Yes.
Okay.
Yeah, because when you put infinity, think of infinity. Give me a number of infinity. Infinity, you could say million. You could say billion. You could say trillion. Okay? But the top is not changing. If the top is not changing and the bottom is changing, chances are it's going to be in 0. Question. Okay? So that's that. Next question. Oh, let's type it in. It's 8. So there's 8 right there. Next one. Yeah, this one. Okay, now this question, what do you do when you get this question on your homework or test? What would you do? Be honest. You'd probably talk yourself into going to the next problem, wouldn't you? When you feel like that on a test or homework, first thing you should do is graph it. So graph it. You could pull your notes out too. That would help too. All right. So graph it. H of x is equal to 3 plus 3 cosine of x over sine of x. And when you do that, you're going to get, well, you're going to get that. So you got a vertical asymptote going right here. You got a vertical asymptote going right here. You got a vertical asymptote going right here. Does everybody see that? Now I can't draw that because I don't have a whiteboard because I suck. But there, right there, there's a vertical asymptote. Right there, there's a vertical asymptote. And right here, there's a vertical asymptote. So all you need to do is find those vertical asymptotes. How do you do that? You set the denominator equal to 0. So set the denominator, sine of x equal to 0. Sine of x is equal to 0. Divide by the sine. Divide by the sine. X is equal to the inverse sine of 0, which comes out to be the angles of 0 and pi. Everybody with me? And you can type that into your calculator. It's probably not going to give you 0 and pi. The best thing for you to do right here is go to your unit circle. You know that thing I put on the files for you so you would kind of remember? I know, I shouldn't do things like that. Okay, unit circle. And the only two angles where the sine of the inverse sine is 0 and pi. So let's go back to our graph. And we've got a vertical asymptote here at negative pi. We've got a vertical asymptote here. And I'm going to do it in yellow highlight, which you can't see. I'm just not doing very well today. I suck. And then one at pi. Okay, now the reason I'm showing you this is because I can't remember who sent this question, but I guarantee you, when you look at that problem, the first thing you're going to think of is, I have no idea how to do this. When you ever reach a problem like that and they're giving you a function, the first thing you need to do is what I'm doing right here. Dissecting the function, finding out what you know about the function, and then once you get there, then you can attack the question. All right, so this looks like this, something like that, something like that, something like that, and something like that. And you know that, and I think they ask you, and I'm not too concerned with this trash because all they're telling you right here is the convergence. That's basically on what intervals is the function continuous. Well, from here to here, so that's from 0 to pi, not touching either one, and then from pi to 2 pi, and so on. Okay, so that's what that's saying right there. All right, I'm not really concerned there. You can actually see, and you can do a trace. You can do a trace, and you can go to here, and you'll say, okay, that's close to 2 pi. That's close to pi over 2. But that's what that is. Continuous is right here. Let me take my highlighter, These are continuous. This is continuous. This is continuous. This is continuous. And this is continuous. And that's where n is an integer. Okay, n pi. And then n plus 1 pi. So 1 pi, which is here. And then this next one is 2 pi. The next one is what? 3 pi. The next one is 4 pi. Anything having to do with 0 or pi, that's where it's going to be. I'm talking about not a fraction, but just 2 pi. Pi and 2 pi and 3 pi. Negative 1 pi. Negative 2 pi. Negative 3 pi. Why? Right here. Anything having to do with pi as an integer, not as a fraction. Anything having to do with pi, that's where your vertical asymptote is going to be. You can't have, how many zeros are there? There's only 1 0 right there. So you can't put 0 into this right here. You can't put 0 in there because there's only 1 0, and you take care of that right here. 0 times pi is 0. And that's it. You're done with 0. After that, you've got pi, 2 pi, 3 pi, 4 pi, 5 pi. Over here, negative pi, negative 2 pi, negative 3 pi, negative 4 pi. Capiche? Yeah, Hubert, we understand. Okay, what about what's happening as you approach 0? Well, let's go back to our handy dandy. What's happening as I approach 0? So I'm gonna take my lavender and my orange. As I approach 0 from this direction, and as I approach 0 from this direction, what am I reaching? I'm reaching this what? Vertical what? Asymptote. And a vertical asymptote is represented by infinity. Okay? Now they say negative infinity. I would argue, I would just say infinity, but they're saying negative infinity. I don't know why they're saying negative infinity. To me, it should be just infinity. I can't change it, but I guess that's the right answer. No, that's this answer down here. That's that answer. I guess that's the answer, but I don't know why they have the negative infinity, because it's infinity. It goes from negative infinity to positive infinity, but I don't know if that's the answer because it doesn't have a red thing beside it, and it's not green like this one. So I don't know if that's the answer or not right there. I would say infinity. Can anybody elaborate and tell me if it's infinity or negative infinity? Because I don't know if that's the right answer, and I can't change it. Okay, I think it's infinity. All right, what are you supposed to do here? Well, I plugged in. Oh, I know why. I know why they got negative infinity. Because 0, if you plug in 0 here, you'll get a negative. That's why. Probably. But this one, plug in 7 pi over 6. So I'm going to go to the next problem. And I'm going to do limit as x approaches 7 pi over 6. Well, hell, I don't know what 7 pi over 6 is. So I change 7 pi over 6. Change 180 over pi. And I get 6 into 180, that'd be 30. 210. So 210 degrees of 3 plus 3 cosine of x over sine of x. 3 plus 3 cosine of 210 over sine of 210. Somebody tell me what 210 is. Y'all can talk. You can turn your mute off if you want to. What is 210 in trig? Okay, you go pretty
pi
much.
over 6.
5 pi over 4.
Well, no, that's not what I'm looking for, but I appreciate that. But what is 210? What is that? It is a special what? The special angle, Hubert. That's right, class, because it is 180 plus what?
30. It's a 30.
There you go. And that means that this is negative square root of 3. This is negative 1, and this is 2. Now I want you to take these three numbers, which you don't have to see them because it's blurry. You should know them. Okay, take those three numbers, and I want you to plug and chug for the cosine of 210 and the sine of 210 and complete that. Go ahead and do that. Take a second and do that. I'm sorry, I didn't have my conversation piece on. Sorry, Miss Sterling. I just now turned that on. Okay, so that means 3 plus 3. So I'm going to put plus 3. And then I'm going to put parentheses over parentheses. So somebody tell me what the cosine of 210. Oscar had a hunk. A hunk would be negative square root of 3 over 2. Sine is Oscar had, negative 1/2. Now, of course, y'all should be able to do this. I mean, I understand that I'm probably knocking some cobwebs loose right here, but right here, y'all should be able to do this. So, what is 3 divided by 1/2? Somebody tell me what that is. 3 divided by 1/2 is 6. So, this is going to be negative 6 minus 6 square root of 3 over 2. And somebody tell me what happens to that negative and that negative right there. It becomes a positive. And that is, I'm going to put a positive there and a positive there, so that makes it a positive, okay? And that's going to be negative 6 plus, what's 6 divided by 2? 3 square root of 3. And that should be your answer. Look there. It's the answer. What I'm trying to tell you is this. If you will look at the question will basically confuse you. What happens when you graph it? Please don't say it confuses you even more. Okay? Would you not rationalize the denominator first by multiplying top and bottom? Okay, I answered a few days ago. Somebody sent that question. Okay? The only time you need to rationalize is when it's on the denominator. But let me give you a reason. When you're talking about trig, Miss Sterling, This is what we're talking about with rationalizing, algebra. Okay? Algebra is when we rationalize the denominator. When you have the square root of x plus 1 over 6, or you have the square root of x over the cube root of x squared, or you have x minus 2 over the square root of x plus the square root of 3. That's when you either rationalize the denominator or rationalize the numerator. When you're working with a trig problem, leave the radicals alone as far as an answer. Okay? As far as rationalizing, because you don't want to rationalize. Now, you can rationalize, like when you do the special angles and you get 3 over the square root of 3, then yes, you go times square root of 3 over square root of 3, and you get 3 square root of 3 over 9, over square root of 9, which is 3, and that cancels. Now that you can do, but when you're dealing with something like this, and what are all, let me show you this right quick. What are all of these right here? Somebody tell me what all of those are. Those are all numbers. When you're dealing with all numbers and there's no variables in there, they don't want you to rationalize, they just want you to solve. So, Miss Sterling, when you see something like this, you might want to just say, Dana, will pull out the what? Calculator. Because they're all numbers. Whereas these are all x's and numbers. And the only time that I've ever told students to rationalize is when you do the sine, cosine, and tangent of a special angle, and you have the square root on the bottom, and you just clean it up right there. Now, you could do that here, but there would be no purpose for it because you don't have an x up here, and it's in the numerator. The only time you would ever rationalize when it's in the denominator, really, unless you're dealing with a limit. And at this point, you're not dealing with a limit because I've already plugged in the limit. Okay? Does that help? Okay. So I don't know who sent that question. Is it a test question? No. Remember, I'm going to ask you test questions that test your mechanics. The ones that I test your mechanics are the ones with the algebra. It has algebra in it. That's that one. Okay, this is Mr. O'Quinn's question, 2.6, number 14.
You have a work email.
Come on, computer, you can do it. Okay? Now, I'm going to tell you right now, I don't like the way this question's asked, but all you need to do is graph this function. Okay? We'll graph it together. Pull out your handy dandy calculator. Make it smaller. Make it smaller. Okay, whatever. There we go. And y is equal to second radical let me just hit clear. I suck. Second radical 2x squared. I don't like that big X. I don't like that. They put, okay, shut up. Squared minus 16. And graph it. There it is. So I'm going to draw that. of course, some of you are going, well, hell, they don't tell me nothing. Well, I want you to see the graph. So when you do what I tell you, you'll say, oh, that makes sense. Okay, so 1, 2, 3, and it looks like somewhere around, and then 1, 2, 3. Okay, so, technically, they're wanting you to find where the function doesn't exist. That's basically what they're wanting you to find. So we're going to set the radical, not the radical. But what can you not have in a radical with an even exponent, with an even index? What can you not have?
A negative.
A negative. This has got a 2 right here. Now, this is not limits. This is not trig. This is not calculus. This is algebra. There's a 2 right here. If there's nothing there, it's assumed to be a 2. And that is an even index. And an even index means you can't have a negative. So I'm going to set the radical equal to 0. 2x squared minus 16 is equal to 0. Well, why are you setting it equal to 0, Hubert? I thought you said a negative. Well, hold on a second. 2x squared, or 2, pull this out, x squared minus what, 8? 2 is equal to 0. X squared minus 8 is equal to 0. That's not true. So you got x squared is equal to 8. X is equal to positive or negative square root of 8. Now, let's take our handy-dandy calculator and let's take the square root of 8. So, second square root of 8. Enter. 2.83. X is equal to 2.83. So that's 2.83 right here. And that's 2.83. Now, what's in the middle of negative 2.83 and 2.83, which is easy to calculate? 0, Hubert. That's right. So let's plug 0 into our function. Square root of 2 times 0 squared minus 16. 2 times 0 is 0, so that's going to be the square root of negative 16. Bah. So anything between negative 2.83 and positive 2.83 is non-existent. So somebody tell me where the function is not continuous. Sorry, hold on. Somebody tell me where the function is not continuous. And it's okay, y'all can hit your microphone.
$2.83.
Okay, be more specific. Negative 2.83 and positive 2.83. Very good. So you can say it if you want to. The function is not continuous from negative 2.83 to what? 2.83. Now I want to ask you a question. I haven't even looked at the problem, but all of this probably you should be saying to yourself, oh, I remember how to do that. You should. It's all how they ask the question. The finite endpoints for which the f is continuous from left should be negative square root of 2. Oh, he pulled out. That's fine. That would be okay. You could write it as a radical, and that's probably the way they want you to. Yep, here it is. Exact.
Message
Make sure you write that is exact. Yes, the domain is negative infinity. Yeah, that's right. Now, right here, Miss Sterling, it says exact. What does exact mean in algebra? That means you have to use the what? You have to use the radicals. So, just in case you don't know how to do that, I'm going to go back down here. And I'm going to change the square root of 8. That'd be the square root of 4 times square root of 2. And what's square root of 4? 2. Put a positive and negative in front of it. And that's 2 times square root of 2. So your left bound is negative 2 square root of 2. Your right bound is 2 square root of 2. If it says exact, then they want you to write it in terms of what? Radicals. Will I be lenient? Yes. On the test, I will be. But please try to follow the directions, because if I have, so I've got 28 of y'all. If 25 of y'all say, hey, the heck with the directions, that means I've got to change 25 of y'all's answers. So it would be beneficial to use the directions if you can, okay? I'm just being sorry, no count. Okay? So that's it. That's how. So as Miss Sterling said, the domain, the function is continuous at negative infinity to negative 2 square root of 2. Let's pull up our handy dandy graph. From negative infinity, we know that this arrowhead right here on the number line is called negative infinity. We know this arrowhead, since the second grade, is called positive infinity. So I'm going to put in green your domain. There's your domain in green. But again, how do you get to this point? You get to this point, first thing you do is graph. And hopefully some of y'all are saying to yourself, well, heck, if I start graphing these things, I might see a little bit more. Maybe. Last question for today. Well, if it ever comes up. I don't know why it's taking so long. Oh yeah, what should you do on this one when you come to it? Quit. A lot of people get confused on this problem, and it's not that big of a deal. Why isn't that big of a deal? It's not that big of a deal because I got 2 or 3 problems I want you to see right here, but I may not get to. Does somebody tell me what this is called? I'm gonna test y'all to see if you remember what this is called. It's called piecewise function. Yes, but that's not what I'm looking for. Okay. What is it a piecewise function of? What does it represent? Not a lot of people will get this, but gosh, a lot of people will not get it because a lot of people skip this in algebra. Okay, including yours truly. I skip it. Okay, this is not a test question. This is called the function of the greatest integer. Write that down. It's called the function of the greatest integer because the function of the greatest integer basically goes to the greatest integer without going over that integer.
So it's only whole numbers?
Yes. So if you've got a decimal, you either got to go up or down. Okay? Now, that's why it's so important that you remember this, because that gives you, and you always round down, because that would make it go up, round down. If you don't remember this from algebra, then you don't know this rule. And that is A on the right side goes to positive A, and A on the left side, approaching from the left side, goes to A minus 1. And that's very important in this problem. But you don't know that. I'm sorry. You don't know this unless you know this. And you don't know this unless you know that this piecewise function is the graph of the greatest integer function. And the greatest integer function is as follows. F of x is equal to and they usually write the x in kind of a funny way. Or they do f of x is equal to that. And that is called the greatest integer function. Now I'm going to do a table for it, because if you see the table, then you see how to get the piecewise function. -2, -0.5, -0.05, -0.01, 0, 0.5, 0.99, 1, 1.5, and 2. I just picked some problems. I just picked some. So the function says if I plug a -2 in here, the only integer that is with -2 but not going over -2 is -2. -0.5 would be -1. -0.05 would be -1. -0.01 would be -1. And then 0, and then 1, 1, 1, and then, let's see, 1.5 would be 1. Oh, I'm sorry, this would be 0. And that would be 2. And when you graph this, you get the piecewise function. So I'm just going to do, okay, at 2, okay, at 2, 1, 2, x is equal to 2, 1, 2, 1, 2, 1, 2, 1, 2. And I'm going to go down to maybe, okay, so the function basically looks, I'm going to do, that'd be 1, -1, so that would be an open circle, and it goes here, and I'm in a closed circle. That would be closed, and this would be open, and then closed, and open, and then closed, and open. Y'all get the picture? And then open. And it keeps going. And that's why it's called a piecewise function or a step function. Okay? Now, here's the part that you need to see. And I'm going to draw a BA. I'm going to draw a BA picture right here. And we're just going to go, this is 1, 2, 1, 2. And I'm going to draw a big graph there. And I'm going to do this. Now, I'm doing this for a reason. So just give me a second. And I can't get 2, but I'm going to put 2 up here. Can't get all of 2 in. Okay. Now, as I approach, I'm going to use a different color here. As I approach 1 from the left, as I approach 1 from the left, I'm on this line right here. So the only place I can go to with 1 on the left is 0, because I'm right here. But if I approach 1 from the right, there's nothing here, is there? There's nothing here, so I have to jump up here. So what am I approaching? All my numbers from the right, you could say 1.5. 1.5 is equal to 2. Okay, let's go back over here. 1.5, I'm sorry, 1.5 is equal to 1, sorry, is equal to 1. So when you are coming from the right, you're going to be approaching these numbers right here, which is 1. When you're approaching from the left, you're going to be on these numbers because they are less than, right here. Let's go back to the graph. Zeros are less than, right there. So I'm trying to show you that with a big graph so that you'll see when you approach from the left, you're usually going to be here. When you approach from the right, there's nothing here. See right here? There's nothing there. So you have to go up here, and that's 1. So if I approach from the left, I'm going to do this in another color. If I approach 1 or 2, if I approach 2 from the left, then I'm going to be at 1. If I approach 2 from the right, I'm going to be at what? 2. And that's what they're trying to get you to see. It's basically a drill on convergence. Okay, that's what it's a drill on. Okay. I'm trying to get to your, when using my math lab, in my experience, exact values mean you do not approximate. Yeah, that's true. And that's why you don't use a calculator with exact. Okay. Whenever you use, I'll tell you this, and this goes back to the last question. None of y'all are talking, so I don't know what y'all know or not. Approximate, when you see the word approximate in your answer or directions, that means calculator, which means usually decimals, like she said. And when you see the word exact, that means radicals. Okay, I don't know who sent this question, but does that help you? Because that's what they're doing. That's why they're asking you each different time. If you go here and you blow this up a little bit, okay, let me go down. Okay, what happens when I approach 3 from the left? When I approach 3 from the left, I go to 2. When I approach 3 from the right, I go to what? 3. When I approach 4 from the left, I go to 3. When I approach 4 from the right, I go to 4. When I approach -2 from the right, -2 from the right, I'm at -3. When I approach -2 from the left or from the right, I go to -2. That's why you have this rule, which means that one of them is going to be 1 off in your answers right here. Okay? So unless you have something like, something real quirky, you're always going to have a different answer right here, because usually if you go in consecutive numbers, one's going to approach from the left and be that number, and the other one's going to approach from the right and be 1 off, or approach from the left on the negative side and be 1 off, and then the one on the right is going to be that number. This one is not a good one to put in the homework, because when they try to explain it, it could lobotomize you because of what they're trying to get you to see. That's why it's better to do something like this and blow it up, so you can see that when you come from this direction, there's nothing up here, so you just go with this. When you go here, when you come from this direction, there's nothing here, so you jump up to the top. And that basically is what this is doing right here. Okay? Okay, who's got questions? Nobody's got any other questions? Who sent that question, if you don't mind me asking? Did somebody send that question that's in here? The one we just did? Okay. Well, I was wanting to see if I helped answer it. Does that help y'all on those 4 questions, 4 or 5 questions? That help to see some hands? Does that help a little bit? Well, I got 1 hand out of, I don't know how many's in here, but that's good. At least I got 1 person. Let's see. How many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 out of 28. So 21 out of 28 is not too bad. And I know 2 that messaged and said that they were not going to be here today. So I don't think I have any more questions. Please. I'll take a few minutes and we can look at the homework, the test questions, and that'll help you out a little bit. Now let me go ahead and tell you something about the test. If you go into the test and then leave the test, it will automatically shut off. Okay? So some of my Pendleton campus students last semester were doing some unethical things, and they didn't think I would find out about it. So I had to fix that. I didn't want to do it, but I don't have much of a choice when people do stupid stuff. You have to, it sucks for the rest of the class. So here is the assignments, and go to tests. You don't have to go to test in this one. It goes, there's down at the bottom probably. There you go. There's the algebra review, and you got 5 attempts. Now, why did I give you 5 attempts? Well, some of y'all suck at algebra, so that's why I give you 5 attempts. It's not because I, like you or anything. It's just some of y'all suck at algebra. So I give you 5 attempts. And what do? Do I average them together? Or do I take the highest?
Take the
Take the highest.
Take the highest. Okay? So that there's no excuse for what? I didn't see that. You don't have to talk, Miss Sterling. So there's no excuse for y'all not to get 100. She's making fun of 100. All right. That's true. And if you really think about it, I do this with algebra a lot because some of my students think they know algebra and they don't do the homework. If you do 25 questions on 5 different tests, how many questions have you done? You've done 125. Basically, you've done the homework. I know I'm a bastard for doing that, but oh well. Start test. And you can see I don't pull any punches. Most of these questions are going to be straightforward. They're not going to be crazy. They're going to be a lot of shortcuts. Factor the trinomial. That's now if you go out of this and you hit minus or you hit minimize and you take your cursor outside of this window, it will shut the test down. And then you're going to call me and you're going to lie to me and you're going to say, Hubert, there was a thunderstorm here and my computer went out. And guess what the computer does when you go out of, guess what it does when you do that? It puts in there, test was, I think it says test was halted or something like that. When it sends me something that says test was halted, that means you left the test. When it says test is incomplete, that means something like the power was cut off or the test went down or something like that. So when you call me, you make sure you tell me the truth because I'm going to know what it says. The highest score is recorded across however many attempts are taken. Leave the test. Click. Are you sending a question or what? Okay, I guess you're leave the test. Click to another minimize.
She's saying you get the score for like however many you've done up to that point.
Oh, okay, okay.
So just to clarify, if we leave that window at all, it'll shut the test down.
It'll get out. Yeah, it'll cut you off.
So is it like lockdown browser where it'll keep notifications from popping in? Because I know like my email pops in on.
I don't think it'll do that. I think it'll only do it when your cursor leaves. Okay. So as long as you are still in this window, I think you're fine. But I think if you go down here and you click on like a window that you already have open, I think it'll cut it off. All right, so that is now you can't factor out of 5. You could if you like fractions, but this one is reverse FOIL. And I'm just going to go through and show you the different things that I told you I would test you on. Okay, so that's reverse FOIL. That's how to use your calculator vertical and horizontal shifts. I told you family of graphs. And there's a homework question. When does homework terminate? Toward the end when I do a test, basically. Solve the equation. Now you could do this 2 different ways. You could do completing the square. That would be the most difficult way. You could factor out of 5. That might help you to factor out of 5. That would leave t squared minus 8. No, factor out of 5t. Sorry. Factor out of 5t, you get 0 and t minus 8 and 8. Something like that. So that's just a solving the equation. Nothing crazy. Completing the square. Now what does it say? Type exact. So what should you use? Radicals. Make sure you write your answer as a radical. If you take several forms of a test in Hubert's class, how is it counted? He takes the highest grade. Some of these questions are from DAs at the end of the semester. Fill in the question. Okay, what does that horizontal shift mean right there? That means 4 to the left. Okay? The 1/3 means this is family of graphs, vertical shifts, horizontal shifts, and orientation. 1/3 means it's going to be wider. It's going to be stretched along the x-axis or compressed along the y-axis. It's going to be short and fat, okay, because of the 1/3. The 4 is a horizontal shift to the left, and that's what they're asking you there. Again, this is something that we went over. Rationalize the numerator. And if you want to try that over the weekend and and write it down and send it to me, I'll do it Monday, or not the weekend. If you want me to do it Thursday, write it down and I'll do it. But I can tell you right now, that's going to be the square root of 3x plus 5 plus the square root of 3x. That's going to be the conjugate over the square root of 3x plus 5 plus the square root of 3x. And you're going to get 3x plus 5 minus 3x. You're going to get 5 at the top. You're going to get 5 on the top, and you're going to get 5 times 3x plus 5 plus, you might distribute that. I don't know if they want you to distribute it or not. You can. Log of x is equal to -4. Log base 10. That's going to be 10 to the -4 is equal to x using the definition of a logarithm. And 10 to the -4 is 1 over 10 to the 4, which 10 to the 4 is BA number. What is it, 100,000, something like that? 1 over 100,000, 1 over 10,000. Only thing with United States in front of it, thank you. Please don't put the Army. Factor the special product. Shortcut number 2. Got a minus there. 2v minus 7 quantity squared. That's what that is. 2v minus 7 quantity squared. Solve by completing the square. And I told you I was going to put a lot of completing the square, a lot of shortcuts, and a lot of rationalizing the denominator. Write the equation. And okay, this is definition of a logarithm. So that's going to be a to the y. So that's going to be log base t of w is equal to x. That's the definition of a logarithm. That's the first rule I wrote down. And I put a square or a rectangle around it, and I told you to do it. Find the inverse sine of, use the right triangle to blah, 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 blah. And they give you the right triangle right here to work with. So the inverse sine right there, that gives you a clue. You got 11x right there, that gives you a clue. I don't put a lot of trig questions on there, but that's, and they say sine of 2 theta is equal to 2 sine cosine theta. Your identity, I mean your reciprocal there, not reciprocal. Identity, one of your identities right there. If you miss a question, what should you do? You should throw a temper tantrum. There is a exponential. Use the power rule. 125 to the 2/3 power. A to the 9th times 2/3. B to the -6 times 2/3. And simplify. I know we're running out of time, but we still got the rest of the week to go over these questions. Completing the square. Rewrite. That's going to be natural log of x over x minus 3 to the 5th power. No, wait a minute. You got to do this first. That's going to be x minus 3 times x plus 3. And that's going to be times 5. So you're going to do that. That's going to be a trinomial. And then put that 5 to the, and then minus x, that's going to be divided. So you're going to have a division. Division of all this divided by x. And that's rewriting using the quotient rule and the product rule of logarithms. Solve by factoring and setting equal to 0. What the heck? Oh. Describe the graph of h of x is equal to -3x minus 4. You know, you got a y-intercept of -4. You got a negative slope, -3/1, and that's 3 up, 1 over, 3 up, 1 over, 3 up, 1 over, 3 up, 1 over. And that's what that's asking. Rationalize the denominator. So I'm going to multiply by 7xy, because I'll have a perfect square, and multiply by 7xy up here, the square root of 7xy. Rationalize the denominator, square root of x plus the square root of y over the square root of x plus the square root of y. That's going to give you x minus y on the bottom. Factor using the reverse FOIL. It's not a shortcut because 80 is not a perfect square. What should you do if you have to leave the class and not turn in stuff? Communicate, just like your employer. This is for some of our conventional classes. Does Hubert replace your lowest test grade with the final exam? Hell no. I have to say hell no, because some of y'all at the end of the semester, y'all take that question and y'all twist it around and say, oh, I thought you did. That don't work. Solve the logarithmic equation. X plus 7 times x minus 3 is equal to x squared. Using the power rule, bring that up. And since you have the same base, log base e, which is natural log, that's going to be x plus 7 times x minus 3 is equal to x squared. That's the equation. Same thing here, except you don't have an equal sign. So that's going to be x to the 1/2 times y to the 5th divided by x to the 4th. You're using quotient rule and product rule, rewriting. Simplify by writing in radical form. That's the 3rd root of 343, which is what, 7? I don't know if it's 7 or not. I get 7 mixed up sometimes. I suck. Why does Hubert not entertain extra points at the end of the semester? He awards me questions like these and he drops the lowest grades. Heck, I dropped the lowest 4 grades on this test. Maybe I should change it just to 2. This is my Hubert's most missed question. I don't know. Y'all explain that to me. I'm trying to hurry. Find the domain. Set the denominator equal to what? 0. Dang old 7 and 4. Dang old 7 and 4 is your answer. Probably, but you need to check it. That wouldn't be -7. Yeah. There's your answer right there, C. So hopefully you can see I'm not pulling any punches. This is dang old Pythagorean theorem. You can do that on a calculator. Find the inverse of the function. Y is equal to x cubed minus 8. X is equal to y cubed minus 8. X plus 8, the cube root of x plus 8. Be A. And A. Because 30, 30, 30 doesn't equal what? Doesn't equal 100. All right, that's the review test. I tell you what, I will be lenient, and if you do have a question on the review, send it to me as a picture, and I'll go over it tomorrow or the next day. I'll be nice to y'all. Anybody got a question? I probably won't do that with the limit test, but if you send me questions, I gave y'all, if y'all noticed, I gave y'all a little bit of extension on your homework. Hopefully y'all are taking advantage of it. Let me go. Yes. Oh, somebody had a question.
Oh,
Okay.
so when you say send you questions, like it'll only let you take a screenshot, it won't do the ask my instructor, right?
I'm talking about I will be very lenient with the review test.
That's what I mean.
Take your phone out, take a picture of the problem. Since it is an algebra review, I will be lenient and I will help you out and take your questions if you have a question. But I'm not going to do it till the next class.
Okay, no, I was just making sure.
You like cheat on the test, huh?
I was making sure it didn't have like a ask my instructor
No,
button
no,
push
just,
or whatever. Okay.
I will be lenient with y'all on the review trig, algebra trig review test, because that's not material that we covered. That is material that you should know. So I will be open to, if you send me one, email it to me. So it'll go through my email, and tomorrow we'll go over any that you have on the test. I'm not going to do that with the limits test though, but you can, look at the homework, and some of y'all still got some homework to finish, and hopefully you can Ask My Instructor. Okay, I need you to turn off. Let me do the recording. Stop the recording. I still don't understand why they don't do a pause recording. That don't make any sense. They had it on the other one. Doesn't make any sense.